Good morning, my wonderful superhumans. Thanks for coming along on another Sunday morning or a Saturday night or whatever it happens to be. I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, the live stream last week, I actually really enjoyed it. I mean, I like all of these live streams, they're fun to do, and it's really cool getting the interaction going in the chat. But what I thought was good about it last week was that it started with a very specific question and a discussion that came out of Discord and the forum, and that gave it a bit more focus than usual, which was good. And also there were a few really good suggestions that came from it, people talking about things that they had done and ideas that help solve the problem that I was talking about. With the basic premise was, if you're building a house and you are wiring it up, you want to make sure that it's set up for automation from the start, so you're not going to have to go back and rip everything out and change it. So what things do you have to keep in mind when you are setting up a house for automation from the beginning? And there were some really cool suggestions there. It actually made me wish that I had wired my house very slightly differently after that discussion. I think the difference, what I would have done differently, is that instead of running the star topology with the cable going from the switchboard directly to the loads, I would have taken the cable from the switchboard down to the switch location and then back up into the ceiling and then out to the load. Even if I wasn't using it, at least then that loop of cable would be in the wall, and later it would be possible to take a regular light switch and fit it on there and convert the house over to working in a totally non-automated way. So I think that was a really good lesson. So I'm actually going to do a video. It's now on my list of future topics. I'm going to do a video which is on the subject of building a new house or a major rewire, setting it up for home automation and future-proofing it against things that you might want to do. I think that's a cool topic. But right after that live stream, I got a message from user Acebook42, who suggested that I should go out to patrons and other people and ask for input on specific topics and questions, so that instead of just having a whole bunch of random questions coming up in the chat, then I can have some questions come through to me beforehand and I can prepare for them. So looking at the chat, Incognito said, "I'm late, what did I miss?" You missed absolutely nothing except a recap of last week. So, so what I did was I sent out a message to my patrons saying, do you have any questions or topics that you'd like me to address in upcoming live streams, and looking for suggestions of themes. And so after asking me to do that, Acebook42 then immediately sent me 4 questions. And unless I've missed something in my email, I think he's the only person who has sent me any questions so far. So Acebook42, which is James, you will get your questions answered today. And oh, Frank said, has the stream started? I'm not seeing anything. That's weird. Let me still check. I don't even know if anybody can see and hear me. I should have checked that earlier. So, is everybody just chatting in anticipation, thinking that it's about to start and nobody can hear me? Daryl says, good for me. Okay, stream works fine. Thanks, Rilesh. Awesome. So I'm not sure what's going on with Frank's connection. Frank, you should be able to see it. Awesome. Thanks, everybody. So, looking at James's questions. Oh, and I just saw Sion is here as well. So, g'day, Sion. One of James's questions is for you, kind of. It was after the live stream a couple of weeks ago, where Sion was on with me, and the question was, did Sion ever get his fire extinguisher? And during that live stream, there was I think it was a $20 US contribution towards Sion's fire extinguisher fund, and I've sent 30 Australian dollars, which is approximately the same thing, over to Sion. But those fire extinguishers are more like $130 from memory. And given all the things that Sion has had going on with his pick and place machine disaster, we can talk about that in a moment as well. But yeah, that's a terrible situation. I don't think he's had time to go buying fire extinguishers. So that was actually the second question from James. The first question was, how many people do you see actually carrying through with doing our light switches in their house? That is, I have no idea. The whole light switch project is a really odd one because it's a major infrastructure change that you make to your house, and for people to do that, they have to be pretty keen. They really have to want to be doing some fundamental changes to the way their house works in order to set those switches up. And in Australia, it puts you into a bit of a grey legal situation because you are putting permanent wiring in place and fixing things to the wall. It's not it's not the same as if you're working on a hobby project where you build a device and it sits up on the thing and plugs in by USB, and you can just unplug it and walk away with it. If you're modifying your house by putting in permanent cabling of any kind, even low voltage, it could be like 12-volt wiring. If you're putting in permanent wiring and modifying the light switches on your walls, then you could potentially have liability issues. So in terms of how many people will carry through and use our light switches, I don't know, but people do seem to be buying them, as in the little breakout boards. You can make them yourself, of course, just by wiring up some buttons or switches and putting them on a wall plate. But I've sold a surprising number of those little breakout boards that take the illuminated LEDs, the illuminated push buttons, and mount them into wall plates. I'm trying to think of the numbers, thinking about the batches that I've had done. So I've done 4-way, 3-way, and 2-way light panels, and the 2-way can also be used to make a single if you want to. So that covers everything from 1 to 4 buttons. And I've sold, I think, maybe 300 of them in total, something like that. There are a couple of people that have placed orders for like 30 or 40 different sizes mixed together. So I know there are a couple of houses where a whole lot of them have been put in, and there are many people that have bought 3 or 4 or 5 of them. So they're doing at least a partial conversion of their house. And I think one of the issues at the moment, one of the things that stops people from using that type of light switch is that building the controller is not really that easy. If you follow my guide from my video a couple of years ago where I did the rack mount light switch controller, there's a whole lot of manual wiring in that, which really sucks. And you've got to buy the case and then manually cut out all of the fittings for the connections and that sort of thing, and then do a whole lot of wiring of links between the different modules, and there was hot glue involved, and stuff that you really don't want to be doing for a home automation system that's going to be a critical part of the way that your house works. So that is one of the major motivations for working on the updated project. So I know I've waved this one around before, but this is part of the new version of the light switch controller. This was the first prototype of the new metalwork, and I've since changed the way this is set up. This is laser cut steel, and but the final ones are going to be done in aluminium, I think. And so it's got the display and buttons. With this version, I had a Raspberry Pi in here. That's why it's got this funny shaped cutout. You can see that it's not just a rectangle, it's got a little notch just in here. That's because it's got the Ethernet socket there, and then 4 USB sockets for the Pi, and then the Pi I/O is exposed on there. And then this plugs into the Pi, and then along here is where all of the sockets would go that you plug in the light switches. Now the actual updated version of this, which I haven't had laser cut yet, instead of mounting the Pi through the front panel, it mounts it back here, and then there is the long PCB that runs along with I2C so that you can address all of the light switches. Now what I'm going to do is have the metalwork for this professionally fabricated, just like this one. I got this one done at a metal fabrication place just down in Bayswater, and I think having something like this will make quite a difference, because it's no longer a matter of buying a plastic rack mount case and cutting it by hand and screwing things in place and doing bodge wires. If you can have a properly fabricated case and then all of the parts just screw into it, like in this case I've got, you can see riv nuts in here. That sort of thing makes a big difference. I'll see if I can turn it over. So you can see the bottom of the riv nuts, and those, so what happens is that there are holes that are laser cut in the metal, the riv nut goes in, and then it's clinched, and it leaves a permanently attached standoff with an M3 thread through the middle, and then you can just bolt stuff down, and it's very secure. That's a really nice way of mounting stuff. But what that's going to give us is a light switch controller that will be much more equivalent to like a professional level piece of home automation equipment, and I think that will make it a little bit more attractive, and people will be more inclined to install that as a permanent thing in their house rather than bodging together things following my tutorial. And yeah, anyway, that was a long-winded answer to the question from James of how many people do you see actually going through with doing our light switches in their house. All right, now James had 2 more questions, and they are directly related, so I'm going to address them both together. He says, I was always curious to see the data from the temperature and humidity sensor in the crawl space you put in when doing the ambient tile display. And then the next question after that is, and was curious to see the node red control you use now. So I'll show you those. What James is talking about with that sensor is, quite a few years ago I did a project where I put an ambient tile in the kitchen, and that was actually kind of a fun project. And even though it sounds like a really weird novelty sort of thing, that is actually one of the most regularly used home automation things in the entire house. Out of all the things I've done, I thought it was going to be a stupid little novelty thing, but it's something that it's always just there. I'm going to find the, here we go, ambient tile. I'm going to drop this URL in the chat, and this is the episode where I talked about the tile. So this project was it was when I was tiling the kitchen, and we have a strip of tiles around the kitchen that are different textures and colors and things, and some of them are glass. So what I did was put addressable RGB LEDs behind one of the tiles so that I could make spots on the tile glow different colors. And a couple of people have taken that idea way further than me and put crazy displays behind their tiles. But what I've got is just the 4 spots, and then what I can do is use different logic to illuminate those with different colors based on different things. So what I've got is a script that scrapes the Bureau of Meteorology site, and it looks for the UV warning for the day. And if the UV level is going to be above a certain threshold, then it makes the tile glow a certain color, and the color changes depending on the level of the warning. So, in the morning when I'm making school lunch and getting ready to go to school, you can, without really specifically looking for it, you just notice, oh, the tile is glowing purple. It's a really bad UV day today. So it just makes you aware of things without being in your face and without having to go and look it up. So instead of opening your phone, going to the bomb site, looking for the UV warning, it's information that is presented to you in a low-key, casual sort of way, but it's done sort of in the periphery of your vision. It's not in your face. And I use the other spots for different things, like saying on a Tuesday night we have to take the bins out and it glows a different color depending on whether we take out recycling or the green waste bin. So those sorts of ambient notifications are really cool. I'm slightly chasing a squirrel here, but this is background to James's question. In order to control that tile, I got I used a board. It was an ESP 8266 based board, and mounted it under the floor of, I know it wasn't, I think it may actually be an Ether 10. I can't even remember. Anyway, some microcontroller is mounted under the floor of the kitchen, and it's connected to the wire that goes up through the wall and controls the RGB LEDs. And because I was curious and I was putting a microcontroller under there anyway, I decided that I would hang a temperature and humidity sensor off it and just have that under the house. So I've got environmental data coming from under the floor of the kitchen, which is the east end of the house, where there's reasonably good clearance. And there's reasonably good airflow under the house. So we've got, our house is on a block that falls, it's got a little bit of a fall to it. So at the west end where I am right now, the house is pretty much on the ground. At the east end, the far end of the house where the kitchen is, I can walk under the house bent over, like, crouch. So there's a fair bit of clearance under there. And then there are lining boards that go around the outside just to block it off visually, but there are big gaps, so air can flow under the house. But generally, the underhouse area you would expect to be a lot cooler than the general ambient temperature. So, just randomly jumping back, Sam P20 just said, have you considered network-based light switches? Yes, I won't chase that squirrel right now. If you go back years and years and years, where this whole journey started, I had network-based light switches. That's where all this began, and I went away from that. In fact, the Ether 10, which is the Arduino Uno equivalent with onboard Ethernet and power over Ethernet, the reason that board exists is that it was designed to go inside my light switches. And so, yes, I used to have power over Ethernet to every light switch. Let's not chase that squirrel. I'm going to try to stick to the topic. Maybe we can come back to that. All right, so James was curious about the data from that temperature and humidity sensor, which is in the crawl space under the house. And he also wanted to see the Node-RED control that I use. So let's satisfy both of those curiosities. Let's see what we've got. I'm going to go to sharing the desktop, and this is my local Raspberry Pi, which is running Node-RED. This is basically the brains of the house, and I've got a whole bunch of tabs across the top here that you can see. So the first one is just information about the brain itself. So it's got some little shell scripts that just query the data coming out of the Raspberry Pi. So this is running on the Pi. It's a script that gets called off cron. It's really simple. All it does is check the CPU temperature, the GPU temperature, and those sorts of things. The sort of stuff that you would report through like MRTG if you're doing monitoring of servers, same sort of process. And then it just converts that to a number and shoves it into an InfluxDB database. So I'm logging data for the brain, and then I'm also logging temperature and humidity in the light switch controllers. So I've got two, in my house I have 3 switchboards. There is the main switchboard where power arrives at the house. It then splits out to 2 sub switchboards which are inside the house, and they are where all of the automation control is done. One for the west half of the house, one for the east half of the house. And so one of my light switch controllers is in the west switchboard, one's in the east switchboard, and they've both got temperature and humidity sensors inside the enclosure. And that's once again just because I like logging data, and then that's shoving that into an InfluxDB database as well. So nothing interesting there in particular. The lab garage section, come on, why aren't you loading? It's just being slow. Alright, so there is a whole lot of repeated stuff on here. Now one thing that you're going to notice looking through this Node-RED setup is that I've got a whole lot of repeated structures, and what I really need to do is convert a whole lot of these to subflows. It'll just make all of this neater. What you see is like there's a slight difference here. This bench light up here, for example, is not quite the same structure as the rest. But if you look at this area here, this is the control for the office blind, and so I've got, this is a voice control input coming from she who shall not be named, so I can tell someone to open and close the blinds. It goes into the office blind, which is a switch, and then I've got, anyway, I won't go into it. There's a whole bunch of stuff there. It splits depending on whether you're wanting to open or close the blind. It sends an on or off message. It then makes an HTTP request. And what you can see here is that I'm still using HTTP to some controllers, not to all of them. In fact, a lot of the stuff now uses MQTT, but some of this was done in the very early days before I was using MQTT. I only started using MQTT, I think, about 10 years ago, 9 years ago, something like that. So you can see lots of repeating patterns, and this is where I need to simplify things. I need to convert it into things like subflows. So this is, I was having a conversation yesterday with my friend Andy, who is the guy who actually introduced me to MQTT, and we were talking about Node-RED and Node-RED versus Openhab and Home Assistant and how they compare. And when I switched over to using Node-RED, what I was switching from was a combination of Openhab and a whole bunch of custom scripts that I'd written. So I'd written some code that was essentially the logic engine. One thing I really haven't liked in the past about Openhab is the way the rules engine works. So what I was using Openhab for was primarily maintaining a knowledge of state of each device and providing a user interface. It was just to use the Openhab app to be able to have a nice way to control things through the phone. But I don't think I ended up with any rules in Openhab. I'd messed around with them, but they were a total pain, so I gave up. And what I did was hung my own logic engine off the side of it, and I could write my own code to do different events based on different things. And so it was to get rid of that I started using Node-RED. And one of the major differences between something like Node-RED or any block-based programming language like this and writing code, or the experience that I've had anyway, is that you have to think in a slightly different way. And for me at least, I find that Node-RED can become very repetitive. As a programmer, what you try to do is take a block of functionality and only use it once. I mean, this is I could get off into all sorts of esoteric discussions here. I'm going to avoid it. But the general principle is that you only do things once, and then you call that multiple times, or wherever you need to call it, so that if it needs to be fixed or changed, it's all changed in one place. You don't copy, the dry principle, don't repeat yourself. So you don't have the same chunk of code copied and pasted multiple places through your project, because that makes it really hard to maintain. If you have the same chunk of code that is repeated many times, what you do is take that chunk of code and you split it out, create a function or whatever your particular language uses, so that conceptually you have one place where that logic occurs, and then you call it from all the different places. So I found that moving to Node-RED, I'm much more reliant on copying and pasting. And what I find that I'm doing is, if I want to set up a new device, like say I need to set up a new light somewhere, what I'll do is select this whole chunk of this flow and I will just copy it. So I'll go select, copy, and then paste, and now I've got a big chunk of a flow sitting here, and I shove it somewhere, and then go through and edit the values and things in it, like change the MQTT topic or what it's calling out to for sending its updates, change the variable it's using for maintaining the state. And that really sucks, because there is scope for error. I've made mistakes in the past where I've forgotten to do something like change the name of a global variable that stores the state, and then I've got multiple devices trying to share the same state. And I know that there are ways to do this much better, like using subflows, and also you can write custom nodes. So what I could be doing is writing a chunk of logic in JavaScript and putting it inside a node, and then I could make all of this really simple. Like each of the flows that you see here could consist of only a couple of nodes with a custom node in the middle that has a function that does exactly what I want it to do in terms of the way light switches behave. So what you're seeing here is a little bit of a mess. It's like a naive beginner's approach to how you would set up stuff in Node-RED. And I'm fully aware of that. People right now who are watching, who are Node-RED experts, probably look at this and go, no, you don't do it like that. Yes, you're right. Anyway, I'm going to get to the whole data under the kitchen floor eventually. We will get there. So what else can we see here? Oh, hang on, let go. Oh no, living area. Kitchen, yeah, there's a whole lot of stuff there. It's just the same. Oh, okay, interesting. What you can see down here is, and I wonder if I can zoom in on this. This might be, I don't know if there's native zoom in Node-RED, but I should be able to just zoom in the browser, I guess. Yes, I can. Cool, might as well take advantage of this resolution. So what you can see down here is conservatory temperature. This is coming in from MQTT. And if we look at the details of that, it's subscribed to a topic of conservatory/temperature. Now, topic naming, that's a whole other big squirrel, or it's actually like a, what's a group of squirrels called? It's a herd or a flock or a whatever of squirrels to discuss, and that is going to come up very soon, because I'm going to get my friend Andy on here and we're going to be doing some stuff about MQTT and topic structures. Now, this is how I was setting up topic structures in the very early days. So this is from many years ago, and so what I did was have a topic structure which was just location or room, and then the name of the variable. And that can be useful in some ways because it groups everything by location. But the thing is that with topic naming or with data of any kind, you want to be able to slice it across multiple axes. Often you will want to look at something in a location. So you might look at a room and say, tell me everything about that room. I want to know the temperature, the humidity, the level of illumination, whether the lights are on, whether the blinds are open or closed, whether the windows are open or closed, whether the heating is on, what is the heating set point. all of these parameters in relation to one specific location in your house. But you might also want to say, I want to know the temperature across every room. So you want to see a whole bunch of temperature values. So what you're doing is slicing the data by the data type, not by the location. So tying your topic structure into location data value is intuitive and it seems obvious, but it's not necessarily the best way to do it. And there are other things that can be used as well, using tags and other methods that are not part of the way that MQTT topics work, but that can be layered on top of it to give you multiple views of your data, so that the data sources are not hard mapped onto a structure like this, but are available to you in different views, so you can see it in different ways. I'm not going to get into that in a whole lot more detail right now. That is going to be covered in the future, and with Andy's help, because he is the expert in that area and has done really cool stuff. So anyway, getting back to this. So the point I was getting to here is that I've got data coming in from MQTT, which is conservatory temperature, and it's going to this little node here. Now this node is a user interface chart which comes out of the dashboard extension for Node-RED. So what I'm doing at the moment is using the dashboard to provide the user interface. So where's my phone? Right here. I mean, you're not going to, I could also pull it up on that screen, but I'm just going to show it to you on my phone in kind of a dodgy way. Come on, where is front? Okay, so this is the, no, it's not going to focus there. So this is the Node-RED dashboard plugin just pulled up on my phone. So if I go into the Office Garage section and click the Office Lights thing, you can see the lights turn off. Hey, that lighting is actually pretty cool. I like that. Maybe I should just leave the lights off. So yeah, we've got light coming from the skylight at the moment and not the overhead lights. And I've got bench lights on, so I could turn off all my bench lights as well. But I might just leave the bench lights on and the overhead lights off. So what I'm doing is using the Node-RED dashboard to show data. And here I've got charts. Once again, you're not going to be able to see that on screen. I'm going to pull that up on the browser instead, because you will see that a hell of a lot better. So if I go to shar.local 1880 UI, what you should see here is a dashboard version of what comes up on my phone. Eventually, one of these days it might load. Alright, we'll come back to here in the meantime. So the point is, if I go into conservatory temperature node, it is a line chart, which is one of the elements that you can put into the user interface using the Node-RED dashboard. And the data for this is being stored within Node-RED, or by Node-RED, using whatever storage engine has been defined in the Node-RED config. Let's see if that's loaded. Oh yes, it has. Okay. Oops, I just turned on the fan by mistake. Alright, so what you can see in here is a variety of charts and things. On the screen like this, it looks like a really big mess because I haven't done anything at all in terms of organizing it neatly. I only ever use this interface through the phone, and what it does is just tile everything vertically. So each of these sections that you can collapse, like if I collapse this one and collapse this one, you end up with the major sections, and then they all just stack on top of each other, and you can open up whichever section you want to look at. And you can see in here, conservatory temperature, this is actually the value that we were just looking at. So if we go back to Node-RED, we've got the data coming in from MQTT, going into the conservatory temperature item, and then this is where it's coming back out. It's being displayed as an item in the dashboard. But that is storing the data on the same machine as Node-RED, and it's using Node-RED's built-in storage mechanism. So I've got a few things that are being done like that, but a lot of data now is going into InfluxDB instead. So there were really two different ways at the moment that I'm taking data from sensors and then storing it for reporting. One way is this way, the simple way, and because this is, if you install the dashboard plugin into Node-RED, then all of this is reasonably straightforward. It's pretty simple to set up a chart node and then shove data into it, and you get the data coming back out looking like a chart in your user interface like this. But what I've been doing instead for most data is I push it into InfluxDB. Now this is going to be a whole big topic in itself. I'm not going to get into it super deep right now. InfluxDB is what's called a time series database, and it's very different to what most people think of as a database. It's because when most people think of a database, they think of something like a relational database or an RDBMS, and the way the data is structured in a relational database is totally different to the way it's structured in a time series database. So with a time series database, what you're doing is looking at values over time, hence the name, time series. So it's like having a timeline of values. In a standard relational database, what you'll have is fields, like you'll have records in the database, and you might have a record which is readings at a certain time from different sensors. But there are a few ways you can structure it. I've got to try to avoid following this squirrel because this is a topic that needs a lot more explanation. Most of my professional life has been managing databases and the code related to managing databases. So that was, at its essence, that's what my software company IVT did. We used to run databases of different types. So I could end up diving down that rabbit hole and never come back out. I'll avoid it. But the important thing to remember is that the way a time series database works is that instead of storing a single value that represents something, it stores a series of values that represent that thing over time. And it's really optimized for doing things like storing temperature values so that you can look back historically and see what's happened with it. And because of the way that a TDB is structured, you don't have to keep all of the sensor points synchronized. You don't have to have a record, for example, of what was the temperature from every sensor at 9:01 AM exactly, because your data might come back at different rates from different sensors. They're all on their own independent reporting rates. You'll get some that are reporting every 10 seconds, some are reporting every 10 minutes. A lot of mine are reporting every 2 minutes. And so what you need to be able to do is record those values as they come in and timestamp them appropriately so that you can then go back and see, you can then compare data that may not have values that came in at exactly the same time. You might have a series of values from the kitchen temperature at 2-minute intervals across a 24-hour period and a series of values for temperature under the kitchen floor, 2-minute intervals across a 24-hour period. But each of those values didn't come in exactly synchronized. They might be offset by a certain period or sampled at a different rate or whatever. But what you can do is take those two sets of data and you can overlay them and compare them by running queries against the database and then representing that data visually. And that's what Grafana does. So Grafana sits on top of a time series database, takes the data from it using queries that you can define, and then allows you to visualize it in different ways. So, Grafana. All right. Now this is, once again, it's a bit of a mess in terms of the way it's laid out, but this is just an example of some of the data coming up in Grafana. Let's see, last 24 hours, and okay, so this is a variety of data. I've got all sorts of stuff in here. Some of it is not taking data actively at the moment, so you can see some blank stuff here like bathroom, bedroom, conservatory data. So right now, conservatory, this chart here is where I should be putting the data that is currently going into the UI element in Node-RED. Now, one of the other differences with this is that I'm running InfluxDB on my main desktop Ubuntu machine, which is a quite fast machine with an SSD and a bunch of other disks in it. So it's got lots of storage, lots of processing power. One thing I noticed is that running something like InfluxDB on a Raspberry Pi is not great because it tends to be fairly write heavy, and the SD card in a Raspberry Pi typically is very, very slow. So you end up running out of space very quickly. Now another thing is how do you handle historical data and data thinning and retention policies and all of those sorts of things. Once again, I'm not going to get into that, but the summary is that there are ways that you can configure your database so that it will only retain data for a certain period of time, or it will do data aggregation historically. So you might want to keep every single data point for the last 24 hours, like a data point every 2 minutes for the last 24 hours. And then for the week prior to that, you might want every 1 hour period summarized. So you do a mean average of all of the data within that 1 hour and you collapse it to a single value. And then for the month prior to that, you might want day averages or whatever. So what you can do is have your data progressively collapsed and averaged over time as it goes further and further back in time until eventually you don't keep it at all. And that way your database doesn't just grow forever and you'll very rapidly run out of disk space. So data retention policies and data aggregation, another big topic. I won't dive down that rabbit hole right now. Let's get back to the topic at hand, which is the data from the sensor under the floor in the kitchen. All right, where are we? Looking at charts. So I'll find the specific one for, you can see some air quality values here. Once again, this is chasing a squirrel, but this is data coming from the PPD, which is parts per deciliter values coming out of the air quality sensor, which is inside my 3D printer enclosure just there. See that little white spot just on the tip of my finger that you can see? It's probably only about a pixel on your screen. That is the illuminated display on the front of the air quality sensor, and that's where this data is coming from. So you can see that around this time there was a big increase and then it dropped off again. So we were looking for the underfloor stuff. Oops. Back to house. I was looking for kitchen. Kitchen. Where is it? My computer is being very laggy at the moment, and I seem to have started, like I was clicking around in this just before I went live on the live stream, and it was responding very quickly, and then as soon as I started streaming it's become mega laggy. So I think my computer is working fairly hard. It doesn't like live streaming. So I was talking about using my Ubuntu desktop machine for the InfluxDB data a moment ago. So that machine is not my main desktop. I've got two desktop computers. One is my iMac and the other is the Ubuntu machine. So right now I'm live streaming and this browser is running on my iMac. And what we're doing is looking, this is something that needs a diagram. So what we're doing is we've loaded Grafana. You can see up in here this little local name resolution char.local, char for SuperHouse automation. That is a Raspberry Pi. So I'm connected to port 3000 on a Raspberry Pi to access Grafana. Grafana is then pulling this data from my second desktop machine, my main Ubuntu desktop, and that is where InfluxDB is running. So the data is being pushed from, so what Node Red is doing is pushing the data into InfluxDB on my Ubuntu machine. Now, all of this could be on one computer. It could be on a single Raspberry Pi or whatever other device you use, but I've ended up using my Ubuntu desktop machine for storing the data just because it was starting to load up the poor little Raspberry Pi a bit too much. Now, if the Pi was running a proper disk, which is much easier now than it was up until about a month ago, and it's probably what I will do in the light switch controller, then it'd be much more feasible to do all of this data storage and reporting directly from the Pi. A lot of the time with the Pi, the limiting factor is the SD card. SD cards can be very slow and also fail in nasty ways. I mean, all disks fail in nasty ways, but for some reason flash drives can fail in ways that bring it all down very hard and in ways that aren't recoverable. Now, I've got to refocus. I was looking for conservatory data. Oh, ceiling space. That's an interesting one as well. I'll get back to that. Where was conservatory data? Atmospheric, lab, enviro, kitchen. Here we go. Let's have a look at this one. So this chart is pulling data from two different sensors. It's displaying it on a single chart, but the data is coming, it's just coming out of the database. But the way the data is getting into the database is that it's being pushed by one temperature and humidity sensor that is sitting in the kitchen, and the other one that is mounted under the floor and giving the subfloor temperature. So what have we got here? So this is the last 24 hours of data, and we can see that the underfloor humidity is the lowest value here. It's this very jaggy looking chart. In fact, I'm surprised that it's so jaggy. And the underfloor humidity is reporting as being very low, like down in the 9% region. Oh, down here it's reporting it as low as 4.4%. What's this one over here? 1.9%. Those values don't even make sense. So I suspect that there is a factor coming into this, which is the relative humidity value needing to be corrected for temperature as well. Although interestingly, this is interesting. One thing that you often see if you are plotting temperature and humidity values together is that they tend to repel each other to some extent. It's the easiest way to describe it. So what we can see, if we start from the left here, you can see that the rapidly falling and very jaggy underfloor humidity comes down here, going down, 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 and the underfloor temperature, which is this one just above it, 16 degrees in this case, is slowly rising. So those two values are opposed. And then just along here, I mean, if you squint really hard and you look at the humidity value from here to here, you can see, like if you drew an average line from there to there, you can see that it's rising at the same time as the temperature is falling. They kind of mirror each other. And then it gets really obvious just here. You can see that at this point the underfloor humidity just falls off a cliff and the temperature is slightly rising, which is very strange. That happened at, I wonder if that is because the central heating has kicked in at that point. So you can see, like if we look at the humidity inside the kitchen, it's gone up significantly at that point. The temperature in the house has gone from 22 degrees, it peaks up here at 24.5. I would have expected to see more of a sudden knee going up there, because if that was a result of the central heating. So in terms of its physical location, the sensor that is giving these bottom two values, so the underfloor humidity and the underfloor temperature, that sensor is sitting, I think it's probably about 5 meters away from the main central heating unit for the house, which is a gas-fired central heating system, and it's got a couple of large ducts that come out and then run around under the house and distribute to the different rooms. But when the central heating runs, it emits a fair bit of heat itself directly around the unit. It's not 100% perfectly insulated, which means that when the gas burners are running in it and it's pumping the air through, the area around the central heating unit is also heating up. So it would make sense if this particular increase in underfloor temperature around 7 p.m, which is not when you would expect to see it going up, was caused by the central heating system. You can see that there is a slow general downward trend here, kicks up, and then it goes back to its slow general downward trend, and then down through here, it kicks up again, and once again, as the underfloor temperature kicks up, the humidity drops down. And it does the same sort of thing here on a repeating pattern. So it does kind of look to me like it is a side effect of the central heating. Now what can be really interesting is being able to correlate data and see if there is any causation. Now I'm kind of making up causation here and saying that the central heating is what's causing this effect with the underfloor temperature and humidity. But this is one of the reasons that I'm a really big fan of just recording everything, because what you can then do is take those different values and you can play what ifs and overlay different bits of information and see if there is any correlation. And of course we all know that correlation does not equal causation. So if you see, for example, that there is a particular event that happens and then there is some other value that changes, and those two things look like they are happening synchronized, then it's possible that there is causation between them, but it's not guaranteed. But it's definitely an indicator that you can then dig into that and see what's going on. All right, I'm going to chase a squirrel here just for a minute because this is such a cool story. About 10 years ago, when I did the vehicle data logger for my RX-8, which was part of writing Practical Arduino. It was the final project in Practical Arduino, and it was by far the biggest. It was, I think, something like a quarter of the entire book was just this one project. And so what I was doing was recording data from the engine management system in the RX-8. So I was recording all the usual things like throttle position, RPM, load, temperature, like manifold temperature, and lots of stuff, storing that in a database. And I was also storing GPS values, so that what I could do later is pull that back into Google Earth and generate dynamic records of what happened in the course of the car moving. So you could see, for example, you could overlay throttle position against geographic position, so that you could then see, oh, you're accelerating hard at this point and then decelerating here and that sort of thing, which was really cool. But one of the things that made me scratch my head for a little bit was I was recording the data from the fuel level as well in the database, and I was recording everything very frequently. Like I can't remember the sample rate, but it was probably like every second or every couple of seconds. So I had fairly fine-grained data across a long period of time. And when I plotted the data for the fuel level in the tank, which comes in as a percentage, I think, I noted when I drew a chart of it, I plotted a chart from the data, I could see, I saw a really weird blip in a couple of places, and I wanted to figure out what that was. So what I did was go back into the database, look at the timestamp for where that little blip occurred, and I saw, this particular blip occurred at this timestamp, and then I used that timestamp and looked at the GPS data, and then used the GPS data to pull up a picture on Google Maps to find out where the car was at the exact moment that the blip occurred in the fuel level. And it turned out, right at that exact moment, the car was going over a speed bump. So what I could do is look at the data for the fuel level and effectively reverse that and find the locations of the speed bumps that the car had gone over. Which, anyway, that might sound silly, but I just thought it was cool because it's looking at data and just puzzling over it and trying to figure out what's going on with it. So, where was I? I don't know. I'm chasing squirrels again, even though I'm trying to stay on topic for James's question. So, James wanted to see the subfloor data for this. And, well, I suppose here it is. What can we make of it? It's cold under the house. That's one thing for sure. Now, one thing is that humidity sensors, different types of humidity sensors are only accurate within certain ranges. They're certainly not accurate from 0% to 100%. They have an optimal range in the middle where they can work, and then their accuracy drops off dramatically towards the ends of the range. And it also varies depending on other factors like the temperature. So what would be interesting, and this particular sensor is, I think it's a DHT11, which is not the greatest quality humidity sensor ever made. It's a pretty cheap thing, and so these values that are coming back out from it that are down in the 1.4% relative humidity range, 1.3, I think that's the lowest I can see there. I don't think I'd be trusting those values. That is ridiculously dry. Well, Cable Tie just asked, why am I recording under house temperature and humidity? What did you hope to know from it? Alright, two answers to that. One is the general, which is the one I was just referring to about, I like to record everything, and maybe you can get some useful information from that. For example, if my... okay, I've got to backtrack with this answer. Just before I go down that little side quest. I just like to record data and then figure it out later. And maybe it's a bit of a strange thing, but if I'm putting a device into a location, like I'm installing a microcontroller in some embedded area, and it's going to be, like, I'm not going to see it again for years. It's going to be stuck inside a ceiling or under the floor or whatever. It's a very small extra trouble to stick a sensor on it, like even just a temperature sensor is really useful, because you can see things like whether your device is overheating, like in the light switches that are mounted inside the wall. One of the things with the PoE light switches that I used to run years ago was that the boards would get quite hot. And if it's inside a wall that also has insulation in it, then the whole thing is inside a small cavity surrounded by insulation, and the board might run 10 or 20 degrees hotter than if it was just sitting in free air. And being able to see that and just look at the temperature in that light switch and see that it's running stinking hot could be an indication that something is wrong and you want to do something about it. So I'm a big fan of just record lots and lots of data and then poke around in it later. And most of the data is going to turn out to be irrelevant, things you don't care about. You can't learn anything from it, but sometimes you can, like that thing of logging the fuel tank level every 1 or 2 seconds, and then that can be correlated to things on the road. So, excuse me. Now, as an example of where that can play out in a semi-useful way, if the central heating system fails, and this has happened several times, the ducts have, like the outlet ducts have either split or come off, like the tape dries out. We've had problems with cats sitting on top of the ducts because they like the warmth, and that then makes the that then puts pressure on the connection between the, I'm doing lots of hand waving, it doesn't really help. So we've got the duct connected into the outlet of the central heating unit, and then it gets pulled off. Or maybe a joint between 2 ducts starts to sag and then it splits. A couple of times that's happened, and we'll have the central heating system running and we're thinking, why isn't the house getting warm? It's freezing in here. And I crawl down under the house, and under the floor space, it's beautiful and warm. I could just sit there all day. And in the house it's freezing because the central heating unit is just pumping hot air out directly under the house. Now the underfloor sensor would show that up in a second. Like if I pulled up the page of charts on on Grafana, or even if I had it coming up on my phone on the Node-RED dashboard, then I would see the underfloor temperature go whoop, shoot right up, and I could say, yep, something has gone wrong with the central heating unit. Now, do you go to the trouble of setting up an underfloor temperature sensor to discover maybe 5 years from now that the duct has fallen off your central heating unit and you need to do something about it? No, I didn't set out with doing the sensing for that specific purpose. I wasn't thinking ahead to using it to detect that situation, but that's just one of the side effects. No, not a side effect. What's the term for it? There's a specific term for when unexpected consequences, I suppose. You've got this information, you're charting it, things happen, and a lot of the time when you're looking at the charts, things will be abnormal, and then you think there's something going on here because this value doesn't normally change like that. Now, do I sit here and look at these charts all day? No, I don't open them very often, but it's still useful. Now, okay, what shall we talk about now? Alrighty, so let's go back to the front camera, and I'm going to, alright, while I've been answering James's questions, I have been totally ignoring the chat, other than, 1 or 2 things that just caught my eye. So I'm going to go for a quick scroll back and see what else. So one thing I totally forgot to do, I sent out an email to my patrons asking them for questions so I could think about them in advance of the live stream, but I didn't send out a notification to my GitHub sponsors, and I'm really sorry about that. I'm going to I'll try to be a bit better about this in future. So what I'll do is set up something that allows both patrons and GitHub sponsors to send questions through. So, and on that subject, I try to avoid promoting Patreon and GitHub sponsors and those sorts of things, because my general approach to it is that I'm not here to sell steak knives and get everybody to subscribe to my newsletter and send me money. I'm here to talk about fun tech things and get inspiration and ideas from you just as much as I provide here. But GitHub sponsors has a thing where they do donation matching to some extent. They've got an account where, if as a content creator using GitHub sponsors, any sponsorship that I receive is matched. I don't know if it's one-to-one, but there is some kind of a matching fund. So for people that contribute to SuperHouse using GitHub sponsors, if you contribute, $5, then I get 10, or some number that's more than whatever you put in. There is a bit of a multiplier effect there. So that only applies for the first 12 months of being on the program, but at the moment it's still within the 12 months because I only signed up for it, I think, about 2 months ago. So anyone that's contributing through GitHub sponsors, whatever you contribute, your money is being multiplied, which is really cool. So, okay. So Zephael said, are you an electrical engineer, and how many thousands of dollars of parts do you have in that room? No, I'm not an electrical engineer. I do not have the qualifications of most of the people watching this stream, which is kind of weird that I'm here describing things and explaining things when there are people on the stream who are have so much more expertise than me. So I began, I've been doing electronics since I was a little kid. I mean, I've told these sorts of stories before. I started when I was about 7 years old, being shown things by an electronics engineer who rented the bungalow at the back of my parents' house. So from the age of 7, he was showing me different things. And then I've just kept going with it ever since then. I started a degree in robotics and digital technology, which is a Bachelor of Applied Science degree. But then I left partway through. I didn't actually complete it, so I don't have a university qualification. And I've been doing software and hardware. So most of my professional life has been doing software. But hardware was my original passion from the time I was a little kid, and I've come back to it in the last 15 years, I suppose. Has been very largely hardware oriented. As for how many thousands of dollars of parts I have in this room, I don't know. Lots and lots of very low value parts. I think that's probably one of the most useful things, is having, like, if you look at resistors are worth nothing, but you need to have a good range of a whole bunch of different values. So what you see in this room is a few items that are reasonably high value, like that microscope is worth probably about $1,000, give or take, by the time you include the cantilever stand and the camera setup and all of that sort of thing. So there are things like that that I've spent a fair bit of money on, but most of it is a very wide range of low value items. And you can see that, like this stack of drawers that you see here, I've got things like every size of M3 bolt from 4mm to like 30mm in length, and every length of M2.5 and M2 and all that sort of thing. So so that's just some mechanicals plus, so that this column here is all mechanicals, and then across here I've got different ICs, and I've got sensors up here and other things. And then over here you can see more stuff stored, and I've got boxes piled everywhere. But most of it is actually fairly low value. What is really valuable is having a very wide range of things, so that if an idea comes to me or I want to work on something, I don't necessarily have to order and then wait a week or two for a particular value of part, because I've got most things right here. Alrighty, so James said, I think there was a Lego brick involved at one point. I think James is talking about my light switches. Yes, the early version of my light switches, when they had Ethernet in them, there were 2 Lego bricks inside each light switch, and I glued them in, used them as a spacer, because the space ended up being perfect to make the buttons end up flush with the panel. But all of that's obsolete now anyway. So, oh, Sion, Unexpected Maker said, what's the reason for moving to aluminium over steel? Weight, price. Partly the actual major reason for that, so what Sion is talking about is for the rack mount light switch controller. The major reason for it is workability. I had a few of these made. In fact, I've got so this one's been cut and painted white. All of these holes that are here, like the buttons and things, I did these holes on a drill press. I made up a jig that holds this vertically and supports it from behind, so I could put this in a drill press and then drill those holes. The rectangular holes here, I started by drilling holes, and then I used a panel nibbler to cut them out. And this being steel, I can't even remember how thick it is. How thick is this? 1.2 millimeter steel. That is thick enough that it is really quite hard to work if you want to cut rectangles and things out of it. Drilling holes is not too much of a problem with a drill press, but rectangular things like slots are a real pain. And oh yeah, just back to here. So what I actually got made in this case, because I didn't know what configuration I wanted for all of the parts, was this front panel is blank. In fact, I have them just over here. So this is what I got back from the metal fabricator. So I designed all of this in Fusion 360 using the metalworking method, whatever it is, workspace, and they laser cut this as a flat piece, and then they ran it through a bending machine to put the bends along the edge and fold the ends around and that sort of thing. So it started like this. I got, I think it was 10 of these as blanks, and then I drilled and cut and painted it. So it was painted with a metal primer and then a gloss enamel to make it look like that. But it was very, very hard to work with. If I could jig it up and do it in a CNC machine, it would be okay. And if the panel was being entirely laser cut, then it would also be okay. So I wouldn't have to worry about anything. But part of the reason for it is that I wanted to be able to make blanks of the panel and then make different types of rack mount devices depending on what I was doing. So I don't know, I'm actually still a little bit undecided about this, and I haven't gone back and had the final version done because I was waiting on the PCBs for the which I now have wherever they are. I could find them, but it'd take a second. I was waiting on the PCBs for the connectors and everything else so that I could be 100% final on how everything fitted inside the enclosure before I got a few of them laser cut, because it cost hundreds of dollars to have those done. I think each one of these panels cost like $20, and I got 10 of them done, so a couple $100 worth of metal work, and I didn't want to screw that up. So I suppose in my head I was thinking, if I do them out of aluminium, then it's easier to rework them. But if it's been 100% laser cut by the metal fabrication company and it's a perfect fit, then I don't care about rework anyway. So I don't know, maybe I'll do them out of steel. I'd be interested to know what people think. Alright, James said steel is cheaper but corrodes much easier. Aluminium doesn't really need to be painted, at least not well, and it won't corrode over time. Yeah, it doesn't need to be painted, but to make it look nice, I think it should be. Having exposed aluminium, it does kind of look cool, but I was trying to go for a very clean aesthetic. So I haven't shown the insides of my switchboards or my racks for a while. That will all be exposed to the world once I get onto the mini-series about the light switch controller. But what I've done in them is gone for a very white, sort of clean Apple-like aesthetic, to the extent that things like the cable management things I've taken out and disassembled and then painted them white and put them back in. So in the I've particularly done this in the east switchboard. So I've got a small rack, and because of the geometry of the space, the rack is actually on its side, which means all of the rack mount devices mount vertically like that, and there is a row of them side by side, and they are pretty much all white, apart from a Unify switch, which is silver. It's like a silvery aluminium color. And yeah, and I think it looks pretty cool. So it's like a rack with all white stuff in it. So I'd probably paint it anyway. So as you can tell, I am responding to comments that were left in the chat probably 45 minutes ago. Yeah. And okay, so this is an interesting point. So Zephael said he should have power and all hookups in back, any controls and display up front. That is a really interesting point, and it's not how I'm doing it, but I'm very interested to hear that comment. Now, the way rack setups are normally done, like if you have a rack mount server, is you have hot and cold aisles in the data center, and so you'll have one aisle which has got the fronts of 2 rows of machines, and then you've got an aisle that will have the backs of 2 rows of machines, and airflow blows through them from the front to the back. So what you have is typically all of the panels in the cold aisle, and then you'll have all of the cabling in the hot aisle, and it's 2 different sides of the machine. But this is going into a domestic installation, and this is something that I really wanted to get some feedback on, because I've spent most of my professional life doing like data center type, software and server management stuff. I've got racks, like I've got spare racks sitting in my garage. I've got more racks than I know what to do with. So mounting stuff like this makes sense to me. This comes naturally. But a lot of home automation systems don't have that sort of infrastructure, and what I had in mind was offering 2 different enclosure types, or 2 different ways of structuring this. What I could do is make a version that's rack mount, and then I could do an alternative enclosure, which could be very similar. It might end up looking like almost the same thing, except that instead of being rack mount, it might have like a full enclosure, and then just feet on it, or something for wall mounting, like brackets underneath, so that you can then attach it into a wall in a wiring closet. I'm not quite sure. I actually don't know what that one should look like. Potentially it could even be done so that it's made very shallow and is designed to be mounted inside a switchboard or on a DIN rail with all of the sockets along the front rather than along the bottom, which it would be if you used this and then mounted it flat. So I don't actually know what that second form factor should look like. But for the rack mount version, the home automation installations that I've seen a couple of really high-end ones. Like I've done some contracting work for let's just say high net worth individuals, and typically the rack setups in high-end houses are not the same as rack setups in data centers, in that they are typically single-facing. You don't have a hot aisle and a cold aisle. You've got a rack that is mounted into an enclosure of some kind, typically inside a cupboard or against a wall, and you don't have access to the back. Everything has to be done on the front. So if you have something like an Ethernet switch where it's got an IEC power socket on the back, what you have to do is unbolt the switch and pull it out of the rack to get to the power cable that comes in the back. So Zephael, thanks for bringing up that point. It's a really interesting point. For my personal application, I want everything accessed from the front. So once this is assembled, there won't be any connections on the back of it. It will basically go in blind into the rack, and then all the connections will be on the front. But if people have different requirements, I'm really interested to hear about that. And I think we can be flexible in it. And Rulesh asked whether I plan on selling a fully assembled one. Yes, I do. What I'm going to do is sell individual modules. So I'm going to sell the PCB, the I2C interface, which has got the MCP 23017 on it, in 8, 16, and 24 port versions. So you can then just build them in, use them with whatever microcontroller you want, run whatever code you want. I'm also going to do the control panel, which has got the display on it and the navigation buttons, which connects to a Raspberry Pi, so you can use that for controlling the Pi. And the idea is that having all of this combined together into a single light switch controller is one application for these modules, and it's going to all bolt together nicely and everything just plug in with IDC leads, so it's a super neat installation and a very quick setup. But you can also use those modules for other things if you wanted to make a different device. So that was actually one of the reasons that I was wanting the metalwork on this to be reworkable. I want to be able to have like a standard blank and then cut it differently to make different devices. For example, make a little NAS. What you could do is put a Raspberry Pi in here with a couple of disks and then have that as a little network server for your home, or you could build a firewall out of it by putting like a Nano ITX motherboard in here, or 2 Nano ITX motherboards side by side. That's a very low helicopter. And that was actually one of the original motivations for this. When I started looking at designing this metalwork, it wasn't for the light switch controller, it was to build a custom firewall. I was doing something that was very similar to some existing firewalls that you can get that have dual PCBs that slide in from the front, so they have little rails, like little U channels, 2 channels on each side, 1 channel on each side, so 2 channels, and you slide the PCB in from the front. It has redundant power supplies, and then you have like a dual firewall router configuration in a single rack unit. That was actually what started all of this, and then I diverted into using this for the light switch. All right. Oh, CPY Andy said, have you considered in-rail mount controller to module, etc.? Yes, definitely. That is... The thing is that there are so many different ways this could be done that I could derail myself now by thinking of all the possibilities. Right now what I want to do is get this version out with the rack mount and 24-port version, and then from there we can start thinking about refinements. But until I get one done, I've got all of these ideas in my head about alternative enclosures and different things, but I'm trying to keep that as a stage 2 sort of thing. All right. I think am I catching up? No, I don't think I'm catching up on comments. All right. Oh, James said, I think it was a D1 Mini. That was in relation to the sensor under the floor, probably. Oh, and Johnny said, as I recall, it was neath the 10. Yeah, I think it... I'm definitely powering it over the Cat5 cable, but I don't remember what the microcontroller is. I have a feeling that it might have been something ESP8266 based, because I think a few years ago I did over-the-air software updates to it. But anyway, it just runs for years and years. So, yeah, oh, this is interesting. Ecognito3 said, I remember watching that Ambient Tile episode and thinking that was a kind of awful user interface. I think I would be forever trying to remember what the different colors were supposed to represent. Yeah, well, that's a really interesting observation. And I think I had some of those misgivings as well when I was doing it. When I started doing it, I had this vague idea that it would be kind of cool, but I didn't know if it would be useful. And I'm actually slightly surprised that it has turned out to be more useful than I expected. It's one of those projects that has been in daily or multi-times per day use for years now, and it just keeps working. And it turns out that it is actually useful. Like, you look at the tile and it's glowing purple and you think, high UV. Better send the kids to school with sunscreen. Or, oh, I've got to take out the recycling today. So, yeah, there's no indication near it of what the colors actually mean. So if you didn't know, then it would just be a glowing point on a tile that wouldn't mean anything to you. But yeah, it just seems to come naturally, I suppose. So, oh yes, and I finally caught up with Sam P20's question about network-based light switches, which I already mentioned. So Sam P20 went on to say, I'm thinking about making some with rotary encoders that communicate over an RS485 based protocol. Yeah, cool. That sounds like an interesting thing to do. There are many, many different ways to do it. So I was doing it over Ethernet originally. Something like RS485, like a multi-drop serial protocol, would be a much more sensible way to do it in many ways. And I've got a revised version of my light switches that has been an in-progress project for a couple of years. But yeah, I'm not, at this stage, I'm not going to go back to like a smart communications protocol for them. There are definitely advantages to it, to doing it that way. I mean, all engineering is trade-offs. It's all about, do I do it, if I do it this way, I have these limitations. If I do it this way, I have these limitations, and you've got to weigh up the benefits of each. So, Michael Barracuda said, did you consider to use LoRa for a longer distance for the bins project? I have LoRa hardware here, but I don't have any of it in active use. I wonder if I've got it just up here. One of my project boxes for LoRa. Yeah, I've got a whole bunch of LoRa hardware just sitting up there waiting to do some projects with it. And that is something that I really want to look at. Now, if you are interested in LoRa, and I'm not going to go into it in great detail now. Basically, LoRa and its derived technology, LoRaWAN, are a way of doing very long range, very low power, and very low speed wireless communications. It's not an equivalent to something like Wi-Fi. Now, if you're trying to do radio communications between two different points, there are three attributes that you need to optimize, or that you can optimize, and they are a trade-off against each other. They are power, bandwidth, and range. And so what you can do is if you want long range and high bandwidth, which is the ideal, that's what everybody wants, that also means you need high power. And power might be in the form of raw power, or it might be in the form of antenna gain, like having a very focused, a very directional antenna, which gives you more gain, it gives you more effective power in a specific direction, which then allows you to use, to get more bandwidth and more range. But for things like sensor projects where you might want a device that runs on a battery for years, you can't afford to be pushing long range and high bandwidth because the amount of power that you need is too high. So what you can do is, if you want long range, which is good for sensor projects, distributed sensor projects, but you don't care about the bandwidth, you're not pushing through streaming video, you might be sending a few bytes of data every 5 minutes, like values from a temperature sensor, then what you can do is wind the bandwidth way down, and that then allows you to save power so you can get long range. So LoRa, I think the LoRa LORA just stands for long range. I think it might be as simple as that. So LoRa is a radio communications method that gives you long range with low power and low bandwidth. And there are some very good videos about it. I'll just see if I can drop a link into the chat. So the guy to check out for this is Andreas Spears, the guy with the Swiss accent, and he's got a video which I'm just pulling up. I'll see if this is the one that I was thinking of. Oh no, not specifically, but Andreas has a very handy channel where he talks about lots of stuff, and a lot of it is in relation to LoRa. So I will drop his channel in here. I think this is the one. If you want to see more in relation to LoRa, go and have a look at that. Now, I've just noticed there is a super chat that's come in. Let's see. Oh, James. James just contributed $20. Thank you for the knowing that John can be bought fund. Yes, I'm a mercenary. So I have been bought to answer those questions. So, yeah, I won't go into LoRa more. That's for a future, or go and check out Andreas's channel if you want to learn more right now. Mako said, did I have an NBN outage yesterday? Not that I was aware of. Maybe, but I didn't actually notice one. Although yesterday I spent most of the day in the garage moving boxes around and building shelves, because I have a huge storage problem. Until I get to build the super lab and have thousands of square meters of space and dedicated storage areas and lots of shelving, I'm jammed into way too small a space. And so I spent yesterday basically listening to podcasts while I was moving boxes and assembling shelves. in my garage to try to get things up off the floor. Make some room so I can walk through it. So we might have had an NBN outage and I didn't even notice. Philip asked, am I still a fan of Sonoffs? Yes, definitely. I use them all the time, particularly the plug-in S26 modules. All right. Rulesh asked a very interesting question that could turn into a really deep rabbit hole, which is Node-RED a total replacement for Home, for Openhab and or Home Assistant? And the very simple answer is it can be. And the reality is that right now my entire house is running off Node-RED. Well, all the lighting is running off Node-RED. The blinds, the exhaust fans, windows, all of those things. I've got a few extra little scripts. Some logic is still in other places, like I've got code that is subscribed to MQTT and is watching for different events, and then it's acting on that. Things like the ambient tile setup in my kitchen is not running on Node-RED. That's some custom code that is doing things like scraping the Bureau of Meteorology site and then sending values to MQTT to change the tiles. But getting back to the point, what happened was I was running my house on Openhab up until a couple of years ago, maybe 18 months ago, I'm not quite sure how long ago, and I was running on the V1.8, I think it was, series of Openhab, and V2 came out and I resisted upgrading for a while. I've got an Openhab 2 set up running at my friend Chris's house, so that's running things like his nurse call. Well, he's got a system where from his wheelchair using the interface, so he's got the Openhab app running on his Android phone, which is attached to his wheelchair, and the wheelchair is linked by Bluetooth to the phone. So what he can do is use the wheelchair controls to access the Openhab app, and from there he can turn his heater on and off, and he can activate a system that fires off like a nurse call thing. So his carer, he has carers with him 24/7, but his carer might do something like go out of the room and put some washing in the machine or whatever, and he needs a way to be able to notify them or call them for whatever he needs. So he uses the Openhab app on his phone to send a message to MQTT, and there is a little device which has got it's a Wemos D1 Mini with a battery pack. It's got a LiPo pack and a piezo buzzer, all in a little box, and it's kind of like a pager, but it's like a DIY pager, and the carer can take that with them, and when he clicks the thing on his phone, the little pager receiver buzzes because he gets a message via MQTT. I'm going off down a rabbit hole again, chasing a squirrel. So we set up Openhab version 2 on a Raspberry Pi at his place, and that all runs on Openhab 2. But I had a fairly complicated Openhab 1 setup for my house, and my personal experience with the rules engine excuse me a second, I'm just going to take a drink. So my experience with the rules engine in Openhab 1 was that it sucked. I really didn't like the way that I had to set things up, and so what I was doing was using Openhab only for the user interface, and everything else I was doing using my own code, as I was referring to earlier when I was showing Node-RED. And then at some point I thought, this is silly, why am I maintaining my own code for this rules engine when I could use something like Node-RED, which is ideal. It's got a nice graphical interface, and it's got extensions so that it can plug into all sorts of data sources and do interesting things. And so I considered switching over to Openhab 2, which would have meant recreating my entire configuration from scratch, because the jump from 1 to 2 was a fairly major rewrite, and the configuration system changed quite a bit. So what I did was I thought, just as an experiment, I want to see if I can take what I'm currently doing with Openhab and my own rules engine and swap out Node-RED. So over the space of a weekend, I sat down with Node-RED and I set up some rules, basically taking data out of MQTT. The thing is, I was already using MQTT as the back end. I was using that for communication with most devices around the house, including both the control system, like my light switches and outputs, so all the actuators. Well, not all of them, but most of them. So what I could do is treat it a bit like a logical plug board, where I've got sources of data and I've got things I want to control and I've got logic I want to do in the middle. So I just sat down with Node-RED and created some flows, taking inputs and making decisions and then sending outputs. And it was very quick to recreate the functionality that I already had. So things like my RFID implant with the RFID reader, all of that is going through Node-RED now. What happens is that the RFID reader, when I scan the implant, it publishes to MQTT, and I have Node-RED that sees that message and it checks the ID of the tag, and then it makes a decision and it sends a command out to unlock the door. So I then added the Node-RED user interface. So Node-RED dashboard is the plugin, and that gave the user interface. And at a certain point, I had Openhab and Node-RED running, and I could do basically the same thing in both of them, and I just turned off Openhab. And since then, my system has been running, so 18 months later, I'm still running entirely on Node-RED. And the thing is that it started off as an experiment. What I thought was, I will just mess around with this, I want to learn more about Node-RED, I'll set it up, and then once I'm done with that, I'm going to set up Openhab version 2 and get my house running on that. And I just never got around to setting up Openhab. So my house is kind of an example that you can run an entire automation system on Node-RED. Now, it does have limitations. One thing that is a problem with it is the user interface. The Node-RED dashboard is cool for what it does, but I found that it has a fair bit of latency. It has some limitations, like it doesn't handle caching very well. One of the advantages of something like a native app, like the way you can do it through Openhab or using an app with Home Assistant, is that the code is running on your phone, and so things like opening the app is relatively fast, and then it just has to populate data, like the current state of different devices, by talking back to the automation system, getting just the data and then updating the state. With Node-RED dashboard, it's just pulling everything remotely, so it can be really laggy. Now I'll just see, because I've done, I already had it open because I was showing it earlier, but if I come in here and click on Node-RED dashboard, it opens and I'm waiting. Oh, okay. So because I had it open and I only just closed it, it loaded pretty fast. But if I now go into a different area, it takes a little while to open on the screen. You probably couldn't really see that very well on the screen, but but the user interface is nowhere near as polished or as responsive as using Openhab. And that's probably the number one complaint that I get. So my kids don't generally use their phones to control stuff around the house. My wife does, and she really doesn't like the Node-RED dashboard interface because of the lagginess. A lot of the time she'll try to open it on her iPhone and it just won't open at all, or like it'll open but it will take 10 seconds or 15 seconds to come up on the screen. And if you're wanting to do something quickly, you click on it and going 1, 2, 3, 4, 5. I'm not going to subject you to it. You can imagine how frustrating that would be after after you've done it a few times. So what I want to do is set up both Openhab V2 and Home Assistant independently on as an experiment. I'd really like to do a bit of a comparison. A couple of years ago, I did a Home Assistant workshop that was run by my friend Alistair De Silva, and so he runs Home Assistant in his own house and does workshops and things showing people how to use it. So I did his one-day workshop, and he included some custom hardware and things as part of it. I've got the custom hardware and the machine that I was running it on. I can't even remember what it was. It wasn't a Raspberry Pi, it's some other machine, little embedded device, like an Orange Pi or something like that, is currently in one of those little white boxes just down there. So that one of those boxes is dedicated to Home Assistant. It's got the controller set up with the SD card and it's configured, and there is some other bits and pieces. So what I want to do is take the time to set up an Openhab version 2 system from scratch and a Home Assistant system from scratch as a way of comparing them to what I'm currently doing with Node-RED. Alright, okay, so a couple more questions. I'm actually getting close to running out of time, and I've got a bunch more comments to get through. Now, Lee Jones asked a very interesting question. What do I think of voice control and security? I'm skeptical of an always-on microphone. Yeah. One thing that I really want to do very soon, if I can, is get my friend Kathy Reed on. I'll do a joint stream. I've actually been in touch with her about doing this, and she's open to the idea. So Kathy used to work at Mycroft AI, which is an open source voice assistant company, and she left there in order to go and do further study. I think it was a master's degree, I can't remember, but her further study is actually in relation to voice assistants, and I think it touches on, I can't remember what the specific topic is that she's studying, but I think it's related to voice assistants and privacy and security. So if there is anyone that can talk about that sort of thing, it's Kathy. And yeah, I'd really like to get her on. I've got one of the original Mycroft AIs, the very early one, sitting in a box just down here. And I've got a couple of custom built Mycrofts for voice control. So for those of you who don't know, Mycroft is conceptually similar to the two other major voice assistants that you probably do know of. She Who Shall Not Be Named, because if I say it, mine will respond, and probably a whole lot of viewers will have theirs respond as well. And the voice assistants from the large search company that I also won't name. And so the major difference is that both of those two leading systems, leading in terms of market share, run their devices largely as remote microphones with very little local processing. They do wake word detection, but then once you start speaking to it and giving it an instruction, your audio is being sent to a server farm in the cloud somewhere, and they are doing the processing on bigger, much faster computers. It then could be put into a little device that's in your house, and then the response is being sent back. So it's relying on an internet connection in order to work, and it's also taking the recording from your home and sending it off somewhere externally to be processed. Now, as part of their quality control and their development, what Mycroft do is allow their users to opt into a system where their recordings are analyzed and to help improve the accuracy and those sorts of things. And I've heard recordings that Kathy has shared of what goes on in the background, and it's actually really pretty scary when you hear recordings from voice assistants and what they pick up. What you hear is, because what happens is that the system is recording continuously. It's like a rolling buffer, and the wake word simply causes it to jump into action and start communicating with the external device. But what the external service receives is a recording. I mean, I'm sure it varies depending on different devices and how they work, but what they can receive is a recording that might be a couple of seconds before you said the wake word, up through what you said, and then a couple of seconds afterwards, because it has to try to figure out when you stopped talking. And the recording itself covers more than just the sentence that you said, like the thing you say to wake up your voice assistant and then the command. It's what happened before, it's what happened after it, and it's what's happening in the background while you're talking to it. And I've heard a few of these recordings, and it's pretty scary because there are things like you will hear the end of a conversation that happened right before you started giving the command. You'll hear people talking in the background, you'll hear arguments, you'll hear all sorts of stuff going on inside the household that is not just the person talking to the voice assistant. Anyway, this is a huge topic. I could go off on this for a very long time, and I am not the expert. Kathy is the expert, so when I get her on the stream, that is the time that we should talk about all of this sort of thing. Okay, all right. Johnny, oh, okay, so Mike. Hey, Mike. Mike said, this is why I use Clockwork for all this. I only have to lay out config. Yes, so for those of you that don't know, I've mentioned Mike in previous live streams, actually. Mike does industrial automation, and Clockwork is his software system that he uses for managing big robots that move heavy things around. And so it's I mean, Mike can explain this far better than I can, but it's his internally developed automation environment, which I believe is all open source, and he developed it for industrial automation and like moving stuff around in shearing sheds, and it can also be used for many other things as well. So it's a way of defining inputs and outputs and events and logic and all of that sort of stuff. It's very cool. I won't get into that right now. There may be links, or there may even be videos around of Mike doing talks about this, because he has done talks about it at the Open Hardware Miniconf a couple of times, at least 2 times, maybe 3 times or more. And there might be videos of that online. Okay, so, and Lee said, Node-RED is a replacement for the automations and scripting logic, but my understanding is it doesn't do the front end UI, so it can't totally replace Home Assistant or Openhab. In general, yes, except that there are plugins that give you the UI, like the one I showed earlier, like Node-RED Dashboard. Now, I am almost out of time, and I'll try to get through some of these. So James Harris asked whether I've seen the range of Tasmota convertible ARLEC plugs available at Bunnings. They're Australian certified. There's also a newer model that includes power monitoring for $20 Australian. Yes, I have, and I have some right here. sitting in a box ready to do a video about that exact subject. So there are certified devices that can be converted to Tasmoda. Another big subject. I won't get into that right now. But James, thanks for pointing that out. That's very cool. So for people that are worried about things like certification of Sonoff, because Sonoff devices have not been, most Sonoffs have not been certified for use in Australia. There are 2 versions of the Sonoff that have been certified. They were certified by a Melbourne-based company called Oikotech, who paid to have all of the testing done, and they are full 100% legit certified. But but they're only certified if you buy them from Oikotech. That's it's kind of one of the weird things about the way Australian certification works. If you, this is another can of worms that I don't really have time to open right now. But so these 2 particular models of Sonoff have gone through certification, and Oikotech has paid for that certification to be done. So the certificates have been issued in Oikotech's name. If you buy those devices from Oikotech, that certification applies. If you buy the exact same device directly from Outage, they're not certified, even though they are physically the same device. So yeah, that's because the company that has paid for the certification puts their sticker on it, and it has the certification number and all of that sort of thing. Anyway, that's a subject I won't get into right now. Andy pointed out. So my friend Andy, who is my MQTT expert, said to Lee Jones, "Have you considered Mycroft with a wake word?" Thanks, Andy. I should have read down ahead. He'd already answered that one. So what? Andy said no about something, but I don't know what it was in relation to. Zephael said, weight sensors under the kitchen floor that give you your weight updates when you open the refrigerator. Yep. Oh, and James Gorman pointed out, MQTT Explorer is awesome for doing test and debug. Yes, that's a really useful tool. And there are many other tools that are similar to it as well. So one of the things with MQTT is that it can be a little opaque. What I mean by that is sometimes you can be publishing things to MQTT and you don't know whether it's working. Now, once you've got some experience with MQTT and the command line tools, it's actually pretty easy to figure things out. Like if you can subscribe to the wildcard topic in verbose mode and see like every message that's going through the server or through the broker, and you can see what the you can see who the what topic it was published to. You can see what the message was, etc. And that can really help you with debugging some things. But things like MQTT Explorer are nice because they give you a GUI that you can point at your MQTT broker and you can see messages and you can publish to specific topics, and you can watch topics and do it all in a nice little GUI. Now, it doesn't really do anything that you can't do on the command line, but it does put it into a nice, concise place that that lets you interact with it in a more easy way. I personally prefer working with the command line tools, but that's fine. So, all right. Oh, and Andy pointed out as well that Mycroft is open source, so you can build and use your own microcontroller board and inspect the open firmware. Yes, that's right. I kind of cut myself off at that point, but when I started going down the track of privacy and security and cloud processing of the audio, one of the major driving factors behind Mycroft's creation was trying to resolve a whole lot of these privacy issues, and also ultimately to resolve the cloud dependence issues. So it's a big complicated topic. If you are trying to build a voice assistant system, there are more pieces to that puzzle than you might expect. There are a whole lot of little subsystems that have to work together, and typically they are distributed. So some of the subsystems will be in your local device, some will be on a remote server, and then there are coordination systems that link it all together. There are lots of pieces. The objective of the Mycroft project is to open source all of those pieces and allow you to use it either 100% on premises, so you can run everything yourself locally with zero external connection required, or to run part of it locally and part of it remotely. Like you could run your own, if you don't have enough processing power locally, you could run a virtual machine on some service like Linode or whatever and run some of your processing there. But at least then you still got control of it, even though you are reliant on your internet connection. But what they've done is they're working towards you being able to run 100% of the infrastructure on your own equipment. So that's worth looking at. Anyway, that's a big topic, and I want to do like a whole series of things about that. All right. Oh yeah, so James and Andy have been continuing to chat about the ARLEC adapters, and James has pointed out that they're in a range called Grid Connect. Yes. But the one thing to check is that, so this can be a trap. Most of the Wi-Fi, the Wi-Fi smart plugs that you find in the big box stores like Bunnings or whatever the equivalent is in the US and other places have an ESP8266 or ESP8285 in them, and you can run Tasmota on them. But some don't. And in particular, things like the Zigbee-based stuff typically has a totally different chipset in it. You can't run Tasmota on it. So, and it can be a little bit of a trap. Like you can see a range of devices from a manufacturer like ARLEC, and they're all in the Grid Connect range, and some of them might have an ESP in them and you can run Tasmota, and some of them you can't. So if you're going to go down this track, don't just like buy 20 of something assuming that you can run Tasmota on it. Always check first. Either play it safe and buy one, make sure you can get it to work, or have a look online, see what other people are using, and make sure that you're getting one that is known to be compatible. Alrighty. What other things? Alright, so, this is interesting too. Narfla said, this Node-RED repetitive code layout is pretty standard for industrial automation. It has the advantage of being simple to troubleshoot. You only need to look at the problem area. Custom function blocks can be made, but then you risk breaking functionality in other instances when changing them. I've seen it get pretty messy. The focus is usually on reliability and readability instead of eloquent or concise code. That's a very good observation. Yeah, from I suppose the coming at it from the point of view of a programmer, like when I say programmer, I mean someone that's worked more in traditional code rather than block-based code, or the sorts of things you see in industrial automation like ladder logic. It seems frustrating and messy and counterintuitive to have large chunks of functionality repeated like that. But yeah, there are certainly advantages to it. It does mean that if you're looking at a particular piece of an automation process, you've got it all there right in front of you, and you can see the logical flow of what's going through the system. So yeah, Nafla, thanks for that observation. All right, I'm going to rush through. Oh, Thomas Meyer said, have recently completed a proof of concept pulling various sensors via MQTT into InfluxDB and then to Grafana. There's also an option to bring Grafana into Node-RED dashboard via iframes. Cool. Yes, so at the moment what I've shown so far is the UI charts in the Node-RED dashboard, but I don't have any of the Grafana charts integrated into it. But yeah, thanks for that tip, Thomas. So if you use Grafana for your chart, like InfluxDB and Grafana for charting, then you can pull that back into Node-RED as well. Okay, well, one of my monitors just turned off. And it's the monitor which is running OBS, which means I can no longer see my streaming interface. Alright, just turn the monitor off and back on, and hopefully I will have everything back in a second, and then I can see what I'm doing. I'm running blind right now. Oh, hooray, I've got OBS back again. Hopefully nobody else saw an interruption. Okay. Oh, I'm talking about the data again from those sensors. James said, I think that every breeze causes the jaggies in the data. Yeah, that could... I'm thinking about where the sensor is located. It's under the floorboards, and I think it might be attached to the side of one of the joists. So there's probably a bit of breeze going across it. Maybe what I should do is make some kind of an openish enclosure that goes around it and just see if that makes any difference. Could be interesting to have two sensors, you know, put them 30 centimeters apart and have one with an enclosure around it and one exposed, and see if one of them has smooth data. And Thomas asked, is your central heating hooked into the home automation setup as well? Right now, no. That is a totally independent system. I've got some things like... Oh, hang on. My chat just jumped massively. Okay. Alright. I've totally lost what's going on here because I had an internet glitch. Maybe that is the whole NBN thing being a problem. Alright. Oh, I've just noticed that I am way further behind on the chat than I thought I was. And I'm now way past 2 hours. Alright, I'm going to try to rush through, which unfortunately means I'm probably going to skip a whole bunch of comments. No, I don't have the central heating currently hooked into the home automation setup. That is something that has been on my to-do list for a long time. One thing that I find is actually a problem is that I have a lot of projects that have been sitting in an undone state. Like, I've got stuff ready to go and I haven't worked on them because I don't want to work on them until I'm recording the process. But recording the process makes it take 10 times as long as just doing it, and so I never get around to doing it. I've got stuff to integrate my home automation system with the central heating, and I haven't done it because I haven't filmed it. All right. Okay. So Dargs asked, does anyone know what happened to smart energy groups? I'm in the process of redoing my setup to send the serial strings from seg to Node-RED instead with a tiny Pico for Wi-Fi. Actually, I do know what happened to smart energy groups. So for those of you who don't know, Smart Energy Groups was an online community that ran for a few years. It was created by my friend Sam Saby, and Sam came out of the energy industry. He was working in, I won't go into it right now, but basically he had a background doing that sort of thing. And he set up Smart Energy Groups, as a way of providing a dashboard where you could put a device in your house for measuring energy consumption, push the data to it, and then it would plot. And then you could do things like share your data and your dashboard with friends, and yeah, all sorts of interesting things. So he ended up winding up that business a while ago, and he is now working for a company that does security cameras for loss prevention on building sites. And he's not running, so SEG no longer exists, unfortunately, which is very sad. I've got some of his hardware here, and energy monitoring is something I'm going to cover in the future. I might even get Sam to join in that, because he's the expert in that area, even though he's not actively working in it right now. He's the expert. Alright, I've got so many more comments here. I'm going to have to jump off. Oh, Simon. Hey, Simon. Simon just made a comment in relation to the to this. So, for those of you who don't know, Simon runs T-Rex water trucks, which is the company that does the water cannon that you can see right there. And he does a lot of metal fabrication. So if anyone knows about metal fabrication, it's him, and he's the one I should take advice from. So he said, cool rack, I would use steel and powder coat it. I'd avoid alloy where possible. Could you have laser cut panels that screw on, giving you the required holes? I like modular design. Yes, so that is a good point. What I could do is get a generic panel, maybe with a large opening across the whole front of it, and then you have a sub panel that screws on, and then you use different sub panels depending on what is going in it. Yeah, that's an option. I think part of the reason that I was inclined towards using aluminium was just for workability, but that is a bit of a false reason. The only reason that I need workability myself to be able to hack around on these panels is if I get the design wrong and I don't, or I'm not getting the whole thing laser cut. So if I'm getting the whole panel laser cut and it's all fitting perfectly with what I'm wanting to use it for, there's no reason for me to rework it. So it would be silly to do it in aluminium in that case. Oh, an unexpected maker said, I really have a squirrel problem. He's a good exterminator. Yes, I'm always chasing squirrels. Okay. Oh yeah, so James O'Gorman made some comments about Openhab V2. So V2 is nice, you can update all the config stuff without restarting the entire app. Yeah, that was a really big limitation of version 1. It was actually really annoying because of the way my state persistence was set up in Openhab version 1, if I restarted Openhab, what would happen is that it would go through, and there were many services that would get reset. Like, it would set all of the lights to a known state and it would turn everything off, which meant that if I edited the config on in Openhab and I wanted to apply that config, I would effectively black out the whole house. And it meant that the only time that I'd ever mess around with the config is if nobody else is home. And that was very frustrating. So, yeah, being able to edit things live in Openhab 2 is nice. Oh, and Thomas pointed out there's a new node for Node-RED called UI Builder to build lightweight dashboards from scratch. Trouble is you have to know HTML, CSS, and JavaScript, but you have total flexibility in the UI. Interesting. All right. There are way more comments here, but I'm going to have to call it off at this point. Oh, and Doug said, it'll be awesome to hear from Sam about Seg. I'm still using his Seg shield to monitor my power usage. Ended up modding to the serial string it sends to be JSON, so it was easier to deal with in Node-RED. Yeah, the hardware that Sam produced, which was, I think, pretty much all designed by another friend of mine, Luke Weston, did the design on Sam's hardware. So those energy monitoring PCBs and the hardware itself is good. And it's just a pity that the Smarter Energy Group's service went away. But you can certainly still use the hardware. It's all open source. You can push the data wherever you like, which is great. I am going to call an end to it. My original idea when I started these regular live streams was that I would do 1 hour from 10 AM every Sunday. Somehow it became 2 hours, and I'm in danger of pushing towards 2.5 hours now. So I'd better stop, even though there are all sorts of interesting things in the comments, and we can do it all again next week. And in the meantime, make sure you come along to Discord or the forum. So I'm going to stick this in here and go along and join the Discord, and you can chat not just on Sunday mornings but all week long. And I hope you all have had a fantastic weekend so far, and it continues to be so. I'm going to send out, and I'll send out another email to my patrons and to GitHub sponsors and solicit more questions for next time. But I'm also interested to hear from people about what they think about guests. I really liked having Sion on the stream. Sion does a fantastic job with live streams and is much better than I am at keeping up with the chat while he's doing the live stream. I don't know how he does it, but having him on the stream and being able to talk to someone else was really good, and I'd like to do a lot more of that. I've got a big list of people that I would like to have on the stream. A couple of people like Kathy I've already spoken to, and they're open to the idea. There's another friend of mine, Paul Fenwick, who just came back to Australia on a repatriation flight from the US. So he's been working at Valve Software, and he, as of a few days ago, he is now free in Melbourne, but still getting himself acclimatized to the time zone and everything. So I've been in touch with Paul about being on the live stream as well. And yeah, there are many people that I'd like to talk to. So I think what would be nice would be maybe having like an alternating arrangement where I do general Q&A sessions like this one, and have guests. So I wouldn't want to have a guest on every week, and I wouldn't, but having guests on occasionally, like maybe every second week or every few weeks, is a nice way of breaking it up so that it's not just me talking to the camera continuously for 2+ hours. And John McRae said, might be good to have a stream moderator to feed the questions to you. Yes, that has been discussed a number of times, and I have a couple of people that have actually volunteered to do that. What I need to do is get it set up. So the general plan for that is that I'm going to have a couple of moderators who will be watching the questions in the live chat, and I'll have like a private Discord chat going with them, and then they can drop questions into it. And if I pay attention to that primarily, hopefully I won't miss things as much as I do now. Oh yeah, James said OBS can make a virtual webcam that you can push to StreamYard. Yes, I've done that. So there are a couple of problems. When I had Sion on, I did that just through StreamYard natively. I didn't use OBS, but I have also done it using OBS and the virtual camera pushing to StreamYard. The problem is that my computer couldn't handle it. It just freaked out. The fans turned on max and it was becoming, the UI became unusable. It was all jittery. It was doing too many things. It was trying to pull in from cameras. Like the camera I'm looking at right now is my external Panasonic camera, and I'm doing video capture on that into OBS, and then OBS was generating the virtual cam, and then it was going, anyway, computer couldn't handle it. And also StreamYard is limited to 720p, which means that you get lower resolution. I'm streaming in HD at the moment. I need to stop talking, or I'm going to keep doing this indefinitely. So it is time to bid you all farewell, and thank you for coming. I hope you have a great weekend, and I'll talk to you all soon. See ya.